Now in this video, we know that the reaction force in the rod at the bottommost point is pulling force, pulling in nature, and reaction at A is equal to 5 mg. We have already calculated that value. Now the reaction at point B in the rod is also pulling in nature, and the value of the reaction at point B is equal to 2 mg, and the reaction at point C is now pushing in nature, and its value is somewhere around 0. It is in fact it is 0. In fact it is mg, not 0. So you can see a trend that the reaction force at the bottom point is pulling, and it is equal to this is pulling force. The reaction force is equal to 5 mg, and the reaction at the point B is 2 mg, but also it is pulling force, and the reaction at point C is equal to mg, but now it is pushing force. So you can see a trend that the reaction is continuously decreasing as the ball is moving from A towards B, and away from the B the reaction will be 0 at some point, and after that point the reaction will change its direction and change its nature. So the point where the reaction will be 0 will be the point where the reaction will change its nature from pulling to pushing. So let's suppose this point has an angle of alpha, and let's suppose this point is P. Now at this point reaction should be 0. So if the reaction is 0, then mg will be acting in the downward direction, and this force will be mg cos alpha, and it will be mv square by L. So if reaction is 0 at point P, so at point P the normal reaction is in the rod is 0, so mg cos alpha will be balancing out mv square by L, and therefore V will be equal to under root Lg cos alpha. This will be the velocity at the point where the reaction will be 0. Now to extract the second equation, I am applying the law of conservation of energy, and therefore the energy at A is equal to half m VA square, and VA is already under root 4GL. So EA will be this is 2 mgl. Okay, now the energy at point P will be equal to mgh as well as half mv square. Now energy at P will be equal to energy at A, and therefore 2 mgl will be equal to mgh. Now h will be equal to L plus L cos alpha. You can see in the figure. So it is mgl 1 plus cos alpha plus half mv square, where if I put the value of v square, then this will be 1 by 2 mgl cos alpha. Okay, so you can see that this is 3 by 2 mgl cos alpha. In fact, if I cancel out the mgl, then it will be 3 by 2 cos alpha will be equal to 1, and cos alpha will be equal to 2 by 3, and alpha will be equal to cos inverse 2 by 3. So at the point where this alpha will be cos inverse 2 by 3, the reaction will be 0, and at the same point the reaction will be changing its nature from being a pulling force to being a pushing force. Thank you.